Okay, now we're going to go over linear equations and inequalities. A linear equation is an equation that has at least one unknown. If you have one unknown, it's usually written as ax plus b equals 0 or some number. Two variables unknown is ax plus by equals 0 or some number. To tell if something is a solution of an equation, what you need to do is just plug it in. I want to know if 5 is a solution to the equation. So 3 times 5 minus 1 equals negative 2 times 5 plus 12. 5 minus 1 is 4. 3 times 4 is 12. Oh, put my parentheses in the wrong position, so let's go back. 5 plus 12. So I get 12 on this side. I get negative 10 plus 12 on this side, which is 2. This is not a solution. So let's see if 3 is a solution. 3 times 3 minus 1 is equal to negative 2 times 3 plus 12. 3 minus 1 is 2. 2 times 3 is 6. Negative 2 times 3 is negative 6 plus 12 is 6. Therefore, this is a solution. Two or more equations with the exact same solution are called equivalent equations. You can use addition properties of equalities to prove several things. For example, if A equals B and A plus C would then equal B plus C, meaning that if I add the same thing to both sides, it doesn't change my equality value. In multiplication, in the multiplicative property of equalities, if A equals B, then A times C equals B times C. Same thing, I can multiply the same thing on both sides. That allows me to be able to solve an equality. Now, there's a lot of different steps in solving an inequality, but I'm giving you the 5 that I use, and I'm going to be using through the lesson. If you use these 5 in this order, they will always work. Can they be switched around? Yes, but you have to know enough math to be able to switch them around and know how to use them. So we're going to use them the way they are. So my first step is always to distribute. Distribute means that I have numbers in parentheses that I have to hand out, a number in front of parentheses. I don't in either of the first two equations. The second one is lose the fraction. So instead of dealing with fractions, I'm going to lose the fraction and get rid of it so I don't have to deal with it. Neither of the first two have fractions. This third one is combine like terms. Like terms means anything on the right side and the left side of the equation. On this side, there's nothing I can combine, and on this side, there's nothing I can combine. But on this side, I have something to combine, and on this side, I have things to combine. So I will be doing step 3 on the second one. On step 4, bring the variable to one side. On this first one, the variable is already sitting on one side. So my step is to solve. So I skipped over for this first one, 1, 2, 3, and 4, and I'm getting straight to 5. To solve, I will pick up the negative 2 and move it over. When I move it over, I will be doing its opposite, or adding it. So I get 1x equals 6. If I don't know already, dividing by 1 is not going to change my answer, so x is 6. You can check it by putting it back in. 1 times 6 minus 2 equals 4. 6 minus 2 equals 4. 4 equals 4. Check. On the next one, here, there's no distributing, there's no fractions, but I can combine terms. 3y and 5y is 8y minus 2. And 2y and 4y is 6y, and 5 and 3 is 8. Bring variable to one side. I have y's on both sides. I normally bring my variable to the left-hand side. While I'm doing that, I take my constant and move it to the right side. I get 2y equals 10. Divide by 2, y is 5. And this next one, it says to distribute first, and I do have some distributing to do. I have a 4 to hand out. I have a 3 to hand out. So I get 4x plus 12 minus 8x equals 3x plus 6 plus x. Any fractions? Nope. Combine like terms. Yes, 4x minus 8x is negative 4x plus 12. And on the other side, 3x plus 1x is 4x plus 6. Bring variable to one side, and like I told you, I usually bring my variables to the left, my numbers to the right. So I get negative 8x equals 18. Oh, let's go back. Can't read my own writing. 6 minus 12 is negative 6. Divide by negative 8. X is 3/4. I listed the steps again, just so that you would see them while we're doing these next problems. Distribute. For this first one, no. Lose the fraction. Yes, to lose the fraction, I look at just the denominators. What number can 10, 4, and 20 all go into? The correct answer is 20, so I put a 20 out front. So 4 goes into 20 5 times, so I need to multiply this whole thing by 5. 10 goes into 20 2 times, so I need to multiply this whole thing by 2. 20 goes into 21 times, so I need to multiply this whole thing by 1. Once I do that, it takes away the denominator, so I don't need it anymore. So I get 5y plus 5 plus 2y minus 4 equals y plus 7. Now I do not have a fraction anymore, so I don't have to deal with them. On this side, 5y plus 2y is 7y. 5 minus 4 is 1. Y plus 7. Combine like terms. Bring variable to one side. Move this over. Move this over. 6y equals 6. Divide by 6. Y is 1. So my answer is y is 1, and I didn't have to get a common denominator other than placing it out front, and I didn't have to move everything as with fractions. Okay, so using the same skills on the next one, there is no distributing. What does 9, 2, and 6 all go into? And the answer is 18. 9 goes into 18 2 times, so I'm going to multiply all that by 2. We have a problem right here. Remember, when you're subtracting, you must change it to addition and change the sign of everything that's with it behind it. So this becomes a negative 2x and plus 1, not a negative 1 anymore. If you do not do that, you will do all your work, you will mess up the sign, and you won't get the right answer. So always make sure that if you're subtracting, that you spread that sign out in the numerator before you move on. 2 goes into 18 9 times, and 6 goes into 18 3 times. So I get 8x plus 6. 9 times negative 2x is negative 18x. 9 times 1 is 9, equals 3. Negative 10x plus 15 equals 3. Take the 15 and move it over. Negative 10x equals negative 12. Divide by negative 10. X is 6/5. On the next one, the 2 doesn't look like it has a denominator, but I can give it 1 by placing it over 1. Therefore, 6, 1, and 3 all go into 6. 6 goes into 6 1 time. 1 goes into 6 6 times. 3 goes into 6 2 times. So x plus 2 plus 12 equals 10. X plus 14, combining like terms, equals 10. Solve. X equals negative 4. So using those 5 steps, you can work your way through an equation without trying to get stuck. There are different types of linear equations. There's a conditional equation, which are the ones we just did, where x comes out as one value. There are contradiction equation, which is an equation that is false for all values. For example, if the x's would drop out or the variables would drop out, you would end up with two numbers equal to each other, and neither of the numbers equal each other. For example, 5 and 9. That will never happen, so that's a contradiction equation. And then you have the identity equation. In this equation, everything will be true because the x's or the variables will drop out, and the two numbers left will equal each other, just like 5 equals 5. So there are three types of equations: conditional, contradiction, and identity. So let's see which kind we have here. Okay, we're going to distribute 3x plus 9 minus 6x equals 5x plus 5 minus 8x. We're going to have no fractions to lose, so we're going to combine terms. 3x minus 6x is negative 3x plus 9. 5x and negative 8x is negative 3x plus 5. Move your variables to one side. Move your numbers to one side. This drops out and I get 0 equals negative 4. When will 0 equal negative 4? Never. Therefore, there is no solution. On the next one, let's distribute negative 4x plus 8 plus 12x plus 6 equals 8x plus 14. Combine like terms because there are no fractions, so we'll skip the fraction part. I get 8x plus 14 equals 8x plus 14. I can already see that they are equal to each other, but if I do make my moves, I get 0 equals 0. When does 0 equal 0? Correct, always. So the answer is all real numbers. So this is an identity. This is a contradiction. On the next one, I have to distribute here. So I have negative 4x plus 2 plus x plus 1 equals negative 4x minus 8 plus 11. No fractions, so let's combine like terms. Negative 3x plus 3 equals negative 4x plus 3. Bring over my x's, bring over my numbers. 1x equals 0. Now please don't assume that this means that that's one of your special ones as contradiction or identity. Just x can equal 0. This is a conditional, and the condition is it works when x is 0. If x isn't 0, it does not work. So there's an example of all three types of equations that you can get. Normally we get mostly conditionals. Okay, how do we translate things into algebraic expressions? Well, I like to read the whole thing, and then I like to go back and pick out important things. So 5 more than a number x is 20. So I got 5 more than, that means I'm adding a number x. So x is coming, I'm adding 5. Is the same thing as equals, is 20. 4 times the sum of a number z and 3 is 15. So I have 4 times, I have the word sum, z and 3 is 15. First thing I want to point out to you is if you see the words sum, product, difference, or quotient, they usually mean that parentheses are going to occur. So I have 4 times parentheses for the sum. Sum means addition. I'm going to add z and 3 is equals 15. The difference of x and 5 equals the quotient of x and 2. So I have the difference, x and 5, equals the quotient, x and 2. Now, I just told you, sum, difference, product, and quotient usually means parentheses. If you put parentheses in and you don't need them, they won't hurt anything. But if you don't put them in and they are needed, they will ruin the problem. So I see difference, I'm going to put parentheses. Difference means subtraction, so x minus 5 equals quotient. Quotient means division, x divided by 2. Did I need the parentheses? No. Do they hurt anything? No. So if I want to go back now and say, hey, I don't need those parentheses and I want to take them off, that's fine also. 3 less than a number y is 5 times y. 3 less than a number y is 5 times y. Less than, more than, means that whatever's coming behind it comes first. So if it's 3 less than y, then y must come first. So it's y minus 3. Is equals 5 times y. The more you do them, the easier they get. Okay, so if you practice them, you'll start getting the hang of them. Steps for solving mathematical problems. Identify what you're looking for, give names to your unknowns, translate the problem into mathematical language, solve the equation, check for reasonableness of the answer, and answer the question. Now, I gave you other steps in one of the previous lessons, so there's many different ways on how to solve a problem. Okay, these are on your formula sheet. These are the formulas for consecutive integers, consecutive even integers, and consecutive odd integers. Consecutive integers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Consecutive even integers are like 2, 4, 6, 8, 10, 12. Consecutive odd integers are 1, 3, 5, 7, 9. Now, consecutive integers, we're going to the very next one. So the first one would be x, and to get to the next one, we'd add 1, so it'd be x plus 1. Then we add 1 more, and x plus 1 is x plus 2. That's how I got the x plus 2 portion. Consecutive even integers, the first one would be x, like 2. To get to 4, we'd add 2, so x plus 2. And to get to 6, we add 2 more, so x plus 2 is x plus 4. But when we get to the odd integers, people want to do x plus 1, and x plus 3 because they're odd numbers. But to get from the number 3 to 5, you really have to add 2. So if my first number is 3 and my second number is 5, I have to do x plus 2. And then to get to 7, I have to add 2 more, so it's x plus 2, which is x plus 4. So the formula for consecutive even integers and consecutive odd integers are the same. Don't let that confuse you. But your answers should be even or odd numbers. Okay, so the sum of 3 consecutive odd integers results in 45. What are the integers? Okay, so I will need the first 3 odd integers. So x plus 2, and x plus 4. So I take x plus 2, and x plus 4, and it's going to equal 45. So that gives me 3x plus 6 equals 45. Subtract my 6. 3x equals 39. X is 13, meaning that my first number is 13, that's x, then I have x plus 2, which is 15, and I have x plus 4, which is 17. So my 3 numbers are 13, 15, and 17, and they are all odd integers. The sum of 3 consecutive even integers results are in as 60. So I go to my even integers, which are x plus 2, x plus 4, same formula as my odds, equals 60. 3x plus 6 equals 60. Subtract the 6. 3x equals 54. Divide by 3. X is 18, so x plus 2 is 20, and x plus 4 is 22. As you can see, the answers to this are even. The sum of 3 consecutive integers results in 78. So x plus 1 plus x plus 2, that's what your consecutive integers formulas are for your first 3, equals 78. 3x plus 3 equals 78. 3x equals 75 when I subtract that 3. X will equal 25. So x is 25, x plus 1 is 26, and x plus 2 is 27. And like I said, these formulas are on your formula sheet. You just need to know how to use them. Before taxes, Marissa earned $725 by working 52 hours. Her employee pays her time and a half for all hours worked over 40 hours. What is Marissa's hourly pay? Well, we need to split this up into regular pay and overtime pay. So the first 40 hours she works for X amount of money. We don't know, so we'll call it X. So she goes 40 hours for X amount of money. Then 52 minus 40 is 12. She has 12 hours of time and a half, which is 1.5x, for a total of $725. Next one. Before taxes, Jim earned $564 after working 50 hours, not but at regular pay, 6 hours at time and a half, and 4 hours at double pay. What was his regular hourly rate? Well, he worked 30 hours at X rate. He worked 6 hours at 1.5 times the rate. He worked 4 hours at double the rate, and he made $564. Setting him up is the hardest part of it. Solving it at this point should be easy. MCI has a long-distance phone plan that charges $6.99 a month plus 4 cents per minute of usage. Sprint has a plan that charges $5.95 per month and 5 cents per minute usage. When will the two plans be the same? We need to write an equation for both of them. So we're starting with MCI. MCI has a $6.99 charge to start with, plus it costs 4 cents per minute. Sprint has a plan that costs $5.95 per month, plus 5 cents per minute. My question is, when do they equal each other? So I'd move my 0.05m over, and I move my $6.99 over, and I'd get negative 0.01m equals 401 divided by negative 0.01. So m is 104 minutes. Now, what does that tell me? It tells me at 104 minutes they're both the same. But the question is, which one's better when? This is how you figure out which one is better when. Whichever one costs the least upfront money. So in this case, Sprint costs the least upfront money. Sprint is better before or under 104 minutes. And MCI becomes the better one after 104 minutes. So it depends on how much you're talking, which is actually the better plan. So if they ask you which one's the better plan, you need to state which one's the better plan and when it's the better plan. Two moving truck companies charge the following. I have company 1 that charges $35 a day plus 15 cents per mile. And I have company 2 that charges 20 cents per day and $20 per day and 25 cents per mile. When will they be the same? Well, the first one costs $35 to start with and 15 cents per mile. The second one charges $20 per day and 0.25 cents per mile. Move my 0.25 over, move my 35 over. I get negative 0.10m equals negative 15. Divide by negative 0.10. M is 150 miles. So they are both equal at 150 miles. But company 2, because it has the lower amount to start out with, company 2 is better before 250 miles. And company 1 is better after 250 miles. So both of them have their time when they're the best. Okay, mixture problems. Mixture problems seem to be hard for people, so I have the formula on your formula sheet and the formula here. A mixture problem, you take the portion from item A plus the portion from item B equals the whole or the total. So I have the portion of X plus the portion of the total amount minus X equals the whole. Okay, so let's see how we can put that to use on these problems. $15,000 is going to be invested into two accounts. One pays 12% interest and one pays 4% interest. His goal is to earn $1,350 in interest each year. How much should he invest in each account? Okay, so my first account is 12%, so that's going to be remember I had to change 12% to a decimal, so 0.12x. Plus his second account is 4%, so it's 0.04, but it's not x. I'm going to use the total, which is 15,000 minus x equals, what does he want at the end? $1,350. When I solve this, I will find out what x is. Once I find out what x is, I can plug it back in and find out x would be the 12%. I would plug it back in and find out what the 4% is. Let's try another setup. Steve has $25,000 to invest in a 4% account and an 9% account. He wants to earn 8% overall interest per year. How much should go into each account? Okay, so he has a 4% account, which is 0.04x, plus a 9% account, 0.09, total money minus x, equals, in the last problem, we had the total interest. In this case, we do not have the total interest. We must figure it out. I want 8% of the total money. That'll give me my total interest. When I solve it, x will be the 4%, and 25,000 minus the 4% amount will become my 9%. A blend of coffee is to sell for $9 per pound. It is a mixture of $8 per pound coffee and $12 per pound coffee. We need 50 pounds of the mixture. How much of each coffee should be mixed? Well, I'm going to start out with, I'm going to take an 8-pound mixture and I'm going to add it to a 12-pound mixture. My total pounds would be 50 pounds minus X. And at the end, I want to make $9 per pound. This is the trickiest part. Most people get this part, but they don't know when to multiply and not to multiply on the right-hand side. It depends if you have a total for the mixture, cost for the mixture or not, or a total amount for the mixture. If you do not have a total amount in the cost or how much you're getting out, you will have to multiply. A blend of 2 nuts costs $3 per pound. The mixture is a mix of $6 per pound nuts and $1.50 per pound nuts for a total of 30 pounds. How much of each nut needs to be in the mix? Well, my first one is $6 per pound, and I'll add to it $1.50, and the poundage is 30 minus X total would equal $3 times 30. My X would be my $6 nuts, and then if I took 30 minus that amount, I'd find out my $1.50 nuts. So the setup is the hardest portion of it. Okay, in your distance formula, which is on your formula sheet, there are 3 things you can do. Distance equals rate times time. If I change it around, rate is equal to distance divided by time. And if I change it around again, time is equal to distance divided by rate. You need to figure out which one you need to use to set up the problem. One of the 3 will be used in a distance problem. Roger and Bill are running a 10-mile race. Roger runs at a speed of 12 miles per hour and Bill runs at 10.5 miles per hour. To even things up, Roger gives Bill a 0.15 hour head start. When will Roger catch Bill? So let's see, we got total distance is 10 miles. So our distance is 10 miles. So we have Roger plus Bill equals 10 miles. Roger has a speed, that's his rate. Roger's rate is 12 miles per hour, and Bill's rate is 10.5 miles per hour. Time. Bill gives 0.15 hour head start. When will Roger catch Bill? So we don't know in the time how much it's going to take him to get to that 10 miles. But he's getting a 0.15 hour head start. So setting it up like this will not work. So we need to come back and rethink. Because most people want to start out with D is equal to RT, but sometimes it just doesn't work. So you need to start over again and see what we have. At the end, we want time, so we want it equal to time. So Bill has a 1.5 hour head start on the time. When will Bill catch Roger? They're both running a 10-mile race. Okay, so we need to know when they both get to 10, each of them get to 10 miles, and Roger runs at 12 miles per hour, and Bill runs at 10.5 miles per hour. So we have 10 miles at 12 miles per hour, and we have 10 miles at 10.5 miles per hour. Now that we've rethought this, what we have is we want to know when their distances will be equal, or when Roger will catch up. So, and there's nothing wrong with rethinking a problem several times. I want to know when Roger will catch up with Bill. Well, Roger's running 12 miles per hour, and he's doing it 0.15 less than Bill. Bill is running 10.5 miles per hour for X amount of time. So 12x is equal to 1.8, minus 1.8 is equal to 10.5. 10.5x. Subtract my 10.5 and add my 1.8. I get 1.5x equals 1.8. X is 1.2 minutes. So in 1.2 minutes, Roger will catch Bill. So these are probably the hardest in determining what you've got to use. So if you use one and it doesn't work, try another one. But one of the three will work. Car 1 is traveling 40 miles per hour, and 2 hours later, car 2 leaves the same place traveling 60 miles per hour. When will car 2 catch up with car 1? Okay, so if we're traveling and we're looking at catching up, we're doing distance again, so D equals RT. And we have car 1 and car 2. Car 1 travels 40 miles per hour, and car 2 has 60 miles per hour. Car 1 has a 2-hour head start, so he has 2 extra hours. Car 2 does not. So I have 40x plus 80 equals 60x. Move my 60. Move my 80. Negative 20x equals negative 80. Divide by negative 20. X is 4 hours when car 2 will catch up with car 1. Now, if I would have called this x and this x minus 2, I would have gotten the answer of 6 hours. Then I would have had to go back and subtract 2 hours off, since I want to know how long it takes car 2 to catch car 1, not how long was car 1 on the road. So be careful that you set it up correctly, or make sure that you answer the correct answer. Linear inequalities. An inequality contains a less than or equal to, greater than or equal to sign. You solve them just like a linear equality, except if you multiply or divide by a negative number at any point on both sides, you must flip the inequality sign. There are compound inequalities, such as x would be in the middle and you have a max and a min. Okay, these are called closed intervals because both ends are equal to, so they have closed dots. You can have something that is, you have max and min, but only one of the ends are closed. They're called half open or half closed intervals. And then you have intervals where both ends are open dots, so they're called open intervals. Intervals that contain infinity or negative infinity are called intervals, but are not considered open, closed, or half open or closed. They're just considered intervals. Like I showed you before, if you have an equal to sign, you can use a bracket to do things in function notation. If it's not equal to, you would use a parenthesis. I will show you that in a second. Okay, so this first inequality has a closed interval on both ends. So I'll use bracket, -2 to 4, bracket. So when someone looks at it, they know I'm going from -2 to 4, and they're both included. And the next one, it has an open notation on the one side, so I'm going from 1 to 5. 1 not being included, 5 being included. In the next one, I'm starting at negative infinity and going to 2. 2 is not included. That's an interval. And on the next one, everything's bigger than -3, so I'm starting at -3, including -3, and I'm going to infinity. This is a way of taking it from interval notation to function notation. Going back the opposite way. This says it starts at -2. It's less than or equal to x, which is less than 4. Equal to because it's a bracket, no equal to because it's not, because it's a parenthesis. Both of these are not equal to because they're parentheses. This says the 3/2 is greater than or equal to x, because x starts at 3/2 and goes forward. In this one, x starts at 1, not including 1, and goes below. So x is less than -1. So you should be able to write them back and forth between interval notation and function notation depending upon how people want it. Now to graph it, closed dots, -2 and 4, and the line is your x. Open dot, closed dot, your line is your x. 2, open dot, your line is your x. -3, closed dot, your line is your x. If you don't want to use an open or closed dot, you can always use brackets and parentheses. I could do a bracket at -2 and a parenthesis at 4 and do my line in between. I can do a parenthesis at 1 and a parenthesis at 5 and do my line in between. I can do a bracket at 3/2 pointing to the right. I can do a parenthesis at -1 pointing to the left. So open dot, parenthesis, either is fine. Closed dot, bracket, either is fine. So let's solve some inequalities. Remember, they're exactly the same way, the same 5 steps, except for if I divide or multiply by a negative number along the line, I must flip the inequality sign. So, move over the 3. 4x is less than 16. Divide by 4. X is less than 4. Lose the fraction. Multiply by 3. This gets a 1, this gets a 3. So 1x is less than or equal to 6. Nothing changing. Distribute. 3x minus 3 plus 2x is less than 6x plus 3. Combine like terms. 5x minus 3 is less than 6x plus 3. Subtract my 6x, because I always take my x's to the left. And on inequalities, you really should always take your x's to the left, because that way it's easier for you to graph. Negative 1x is less than 6. Divide by negative 1. I'm now dividing by a negative number. The sign will switch directions. So if I was graphing it, negative 6, the x is greater than negative 6. Distribute. 7 minus 2x minus 2 is less than or equal to 3x minus 15. Combine like terms. 5 minus 2x is less than or equal to 3x minus 15. Move my 3x over. Move my 5 over. Negative 5x is less than or equal to negative 20. Divide by negative 5. X is greater than or equal to 4. I must switch the sign due to the fact that I divided by a negative 5. That is the only difference between an inequality and an equality in solving. The steps are the same. Distribute, lose a fraction, combine like terms, bring variable to one side, and solve. Negative 2x, got to get that pen on. Negative 2x minus 2 is greater than or equal to 4x plus 12. Subtract your 4x, add your 2. Negative 6x equals 14. Divide by negative 6. It's not equals. See, sometimes you do. You skip that step, so make sure you put it back in. Dividing by a negative number, flip that sign. 7/3, negative 7/3. Lose that fraction with a 6. Multiply this by a 2, multiply this by a 3. 4x plus 2 is greater than 3x minus 6. Subtract your 3x, subtract your 2. X is greater than negative 8. Nothing flipping on that one. Put a 1 under it. Common denominator is 5. Multiplies by 1, multiplies by 5. 3x plus 1 is greater than or equal to 10. Subtract your 1. 3x is greater than or equal to 9. Divide by 3. X is greater than or equal to 3. See, we're not flipping all the time, so don't get flip happy. Common denominator 10. Multiply by 2, multiply by 1, multiply by 5. 4x plus 3 is less than 5. Subtract 3. 4x is less than 2. Divide by 4. X is less than a half. Distribute, lose a fraction, combine like terms, bring variable one side, solve. But during your solving, if you divide or multiply by a negative number, the sign switches directions. Okay, this is where you would be going into where we did the trucks and which one's a better deal, and MCI and Sprint. They actually want you to put an inequality sign in and tell them when it's a better deal. Setup is still the same. It's going to cost you $39 for the first one and 0.129x. And the second one is going to be $30 and 0.1415x. You want to know when the first card is less than the second. So all you're doing is putting a less than sign in. You could do it with an equal sign too, because we know wherever they're equal at, the first card is less than the second after that amount, because that has the higher amount on it. So you can do it either way. Okay, compound inequalities are inequalities that combine two. It's compound because they combine two inequalities with the word and or. An intersection is where they both work at. That's an and. It is in the symbol of an upside down U, means and. A union, which is the U itself, means all elements in both sets. That's an or. So in this first one here, I have an upside down U, which means I want an and. That means I want them in both of them. 7 is not into both of them, so 7 is not part of it. They both have an 8, they both have a 10, and that's it. This is the and. In the second one, it's the union or an or. So it doesn't matter who has it, as long as they have it, it counts. So in this case, I have to put both of them together. This is an or. We're going to be doing ands and ors. So ands where they overlap at, where they both have it, or can be in either one. To solve them, you solve them like any other equation. So I'm going to add 3, get x is less than 8. I'm going to subtract 4. 2x is less than 10, so x is less than 5. So I need it less than 8 and less than 5. To be less than 8 and less than 5, they overlap less than 5. So my answer is less than 5. I'm looking for the overlapping. Solve. 2x is greater than 10, x is greater than 5. Solve. 5x is less than 10, x is less than 2, getting ahead of myself. So x is greater than 5, and x is less than 2. Where do they overlap at? That's correct. They don't overlap. So if they don't overlap, there's no solution. That's the sign for no solution. These are also ands where they are together, and don't let that confuse you. What happens is, look at the center, and you have to move what's in the center to both sides. So the first thing I'm going to do is move the 1 to both sides, and I get negative 4 is less than 2x, which is less than or equal to 2. Then I divide both sides by 2, in fact including the middle, and I get negative 2 is less than x, which is less than or equal to 1. These are easier to graph because everything's already placed with the x in the center. So I have a closed dot and open dot and everything's between. Solving these are the same thing. Distribute, no. Lose the fraction, yes. So I'm going to multiply by 2. This gets a 2, 1, 2. So 2 is less than or equal to 2x plus 3, which is less than 22. Look in the center, move the 3. Negative 1 is less than or equal to 2x, which is less than 19. Divide by 2. Negative 1/2 is less than or equal to x, which is less than 19 halves. Close dot at negative 1/2, open dot at 19 halves, colored in between. So if you see one where you have a max and a min and x is in between, that is always an and. Okay, ors. Ors are always separated. They're never together. So you're not going to see them set up like these ands that we just saw. They will always have the word or in them. Okay, so I'm going to move my 3 and get 2x is less than 10, x is less than 5. I'm going to move my 35. Negative 4x is less than or equal to negative 32. Divide by negative 4. I must switch the sign because I divided by a negative number. So, it's less than 5 and greater than or equal to 8. It's an or, so both work. Add 5. 3x is less than or equal to 18. Divide by 3. X is less than or equal to 6. Subtract 2. 5x is greater than negative 5. Divide by 5. X is greater than negative 1. 6 close dot this way, -1, open dot this way. As you can see, they overlap and point out to the sides. Therefore, this is all real numbers. If an and looks like an or, there's no solution. If an or looks like an and in any form, it's all real numbers. An and normally looks like two bookends colored in between. They can be solid or open, it doesn't matter. That's what an and looks like. An or is normally pointing in two opposite directions. That's what an or is. Equations and inequalities. Absolute value tells the distance, not the direction. We've already discussed that in a previous lesson. The boundary points to an absolute value equation are the end values between the two parts of the absolute value. A test value is a number in the boundary area where we're shading, and the margin of error is the amount we can go up or down. To solve for an absolute value, you get the absolute value by itself. You write the equation twice because an absolute value looks like a V, meaning there's an answer on this side and this side, and we have to find both answers. One side will be the positive side and one side will be the negative side. So you set it equal to the positive number and the negative number. Then you solve both to find your boundary points. Okay, so get your absolute value by itself. Your absolute value is by itself on this side, so I need to do nothing except split it into two. On the one side, I write 2x minus 3 equals 11, and on the other side, I write 2x minus 3 equals negative 11 for the opposite side of the absolute value. Solve it, add my 3, x is 7, add my 3, x is negative 4. So it means the x will cross at 7 and negative 4 when I graph this. On the next one, you have to get the absolute value by itself. So the first thing you have to do is move the 15. It's just like solving an equation. The absolute value is your variable. Then you need to divide by 5. 1 minus 4x equals 3. Now that the absolute value is by itself, you set it equal to itself and you set it equal to its opposite for the other side of the absolute value. Subtract my 1. Negative 4x equals 2. X is equal to negative 1/2. Subtract your 1. Negative 4x equals negative 4. X is 1. So it crosses at negative 1/2 and 1. If you have two absolute values, get them by themselves, which they are. Separate them and make one 3x minus 1 equals x plus 5. And 3x minus 1 equals the opposite of everything, negative x minus 5. Move my stuff. 2x equals 6. X is 3. Move my variable and my number. 4x equals negative 4. X is negative 1. Now, one thing I don't have up here, but I want to point out to you, if I solve for the absolute value, absolute value of 2x minus 1 equals negative 3, I don't even need to solve this. I already know it's no solution. If you get an absolute value by itself and it equals a negative number, there will be no solution because an absolute value can't equal a negative number. But you have to get it by itself before you make that decision. Steps to solve an inequality with an absolute value. You're going to do the exact same thing, but you must flip the signs when you put the opposite number on. Okay, so I'm going to split it into 2. That pen, split it into 2 and get x minus 4 is less than 3, and x minus 4 and negative 3, but switch the sign. It's the only difference. X is less than 7. Add 4. X is greater than 1. If I wanted to graph it, I have an open dot at 1, open dot at 7. It's less than and greater than, so it's going to be an and. Something you want to know. An and will have the absolute value with the inequality facing it. An OR will have an absolute value with the inequality going away from it. So this was an AND, so it should look like an AND at the end. This is an OR. We're having the inequality, it's solved, and it's facing away. So 2x plus 3 is greater than or equal to 5, and 2x plus 3 is less than or equal to negative 5. Subtract my 3. 2x is greater than or equal to 2. X is greater than or equal to 1. Subtract my 3. 2x is less than or equal to negative 8. X is less than or equal to negative 4. Negative 4 less than or equal to 1 greater than or equal to. And it does look like an OR. Okay, you have to have that absolute value by itself before you can start, and this first one does not have the absolute value by itself, so I'm going to need to subtract the 7, negative 2, absolute value of 3x plus 5 is greater than or equal to negative 20, divide by negative 2, absolute value of 3x plus 5, flip that sign, it's less than or equal to 10. So this is going to be an AND. It should be colored in between because it's facing the inequality. So I'm going to split it. 3x plus 5 is less than or equal to 10. 3x plus 5 is greater than or equal to negative 10. Subtract 5. 3x is less than or equal to 5. X is less than or equal to 5/3. Subtract 5. 3x is greater than or equal to negative 15. X is greater than or equal to negative 5. 5/3, solid dot less than, negative 5, solid dot greater than, an AND. Negative 3 times 5x minus 2 plus 20 is less than or equal to 1. Subtract 20. Negative 3 is 5x minus 2 is less than or equal to negative 19. Divide by negative 3. 5x, absolute value of 5x minus 2 is less than or equal to 19/3. Split it in half. 5x minus 2 is less than or equal to 19/3, and 5x minus 2 is greater than or equal to negative 19/3. Lose the fraction with a 3 on both of them. So this gets multiplied by 3, this gets multiplied by 3, this gets multiplied by 1. So 15x minus 6 is less than or equal to 19. 15x is less than or equal to 25. Divide by 15. X is less than or equal to 5/3. This gets multiplied by 3, this gets multiplied by 3, this gets multiplied by 1. 15x minus 6 is greater than or equal to negative 19. Add 6. 15x is greater than or equal to negative 13. Divide by 15. Sorry, I ran out of room. X is greater than or equal to negative 13/15. On a number line, 5/3 less than or equal to negative 13/15 greater than or equal to, and it is an AND. We're going to skip this one. We're going to move on to this one. 2x minus 5 over 3 equals 3. 2x minus 5 over 3 equals negative 3. Everybody says, well, why don't you switch the equal sign like you switch the inequality? Well, if you flip an equal sign, what do you get? An equal sign. So pretend we're doing it. Multiply by 3, 1, 3. Multiply by 3, 1, 3. 2x minus 5 equals 9. Add 5. 2x equals 14. X is 7. 2x minus 5 equals negative 9. Add 5. 2x equals negative 4. X is negative 2. And when you graph something, if you really wanted to graph this and see it's not an inequality sign, what you do is you go to negative 2 and put a dot, and you go to 7 and put a dot. You just don't color, because it doesn't color if it's an equality. Analyzing error. So let's say we want to write our own absolute value. If we want to write our own absolute value, it's always the absolute value of x minus the middle is less than or less than or equal to how much I can go up or down. So when I'm looking at this, my middle is 9. That means my mean is 9. And I'm allowed to go up or down 2.9. So in this one, if I want to write an absolute value, I do x minus my middle, 11. And I'm allowed to have a margin of error up or down of 1.2. They're not hard to write as long as you know which one goes where. Okay, this finishes our lesson on inequalities and equalities, including compound inequalities, inequalities, and absolute value equalities and inequalities.